dy dx will be given by what? Again, we shall differentiate exponential function. We still get exponential function. We are on chain rule. Chain rule. We have said when you differentiate exponential 2x, differentiate exponential, you still get exponential. But you come to the power, you differentiate 2x, you get 2. So you multiply with a factor of 2. The same will happen here. When you differentiate exponential, you still get exponential. The same thing. But you come to the power. When you differentiate the power, you get here negative what? Negative 3. You get there negative 3. So you can be able to see you are multiplying with the factor. We can do this one. Y is equals to sine 4x dy dx. We get dy dx. So that one again, if you go back to the table, when you differentiate sine, I'll give you the hint, you'll get cos. So you'll get cos of the same thing. You'll be able to get cos of the same thing. So you'll get here cos 4x. But you come now inside now the function now 4x. When you differentiate 4x, you get what? 4. So you multiply with a factor of 4. So it's the first way of doing a chain rule. First way, because you are still doing the same thing. You can be able to use the chain rule later, and you'll be able to confirm my answer, and you'll be able to see they are the same. Y is equals to ln 2x plus 1. When you differentiate ln, what do you get? What ln does, it takes everything to the denominator. So I'll have here 1 all over 2x plus 1. That's what it does. Differentiate ln x, you get 1 over x. So when you differentiate ln 2x plus 1, it will take everything to the denominator. But you come inside the function. That's where people forget. You come inside the function, you multiply with the factor of. When you differentiate 2x plus 1, what do you get? You get only 2. Here the answer will be 2x plus 1. So there'll be a factor of 2 here, because we have differentiated inside. Whatever you differentiate inside, you multiply with that. You multiply with that all the time. Number V. Y is equals to, we can do another function which was, let's say cos 5x. So dy dx, when you differentiate cos, you get what? Negative sine 5x. But you come inside the function, you differentiate inside the function. Whatever you differentiate inside the function, the brackets, you multiply with it. When you differentiate 5x, you remain with 5. So here the answer will be what here? Negative 5 sine 5x. Final answer will be given by that. So these are the most common functions I think you can be able to do for the sine hyperbolic x squared. When you differentiate sine hyperbolic, you get what? Cos hyperbolic. So you'll get here cos hyperbolic, the same function, x squared. But you come inside the function, you multiply with that. So when you differentiate x squared, you get what? 2x. So here the final answer will be 2x cos hyperbolic of x squared. So basically that's it. You differentiate the function, but you remember to come inside. You remember to come inside always, and you differentiate. Anyone with a question there? Okay, I was on product rule. So the product rule means that when you are differentiating, no, when you have a product means when you're multiplying two functions. The product rule signifies that you can be able to differentiate one, leave the other one as a constant, then you do the vice versa. Then that's why you have u, you can be able to see the u, and then now you differentiate the v. That's why you have dv over dx. Then you do the vice versa, then the v, and then the du dx. The order doesn't matter. You can start with v du dx plus u dv dx because it is addition. Order doesn't matter. So when you have a product of two functions, is for you to be able to come and gauge. I have a product, then I must apply product rule. We shall come later to quotient rule. When I have I'm dividing two functions, I'll apply quotient. Quotient means there's a numerator and a denominator that you want to do what, to differentiate. So let's do this one. The first example you see. So the formula, you'll have to remember it. It's not that hard. When you do a lot of practice, it becomes a bit easier. So when you have, we can do example 1. Y is salama san, x squared, and let's say sine 10x. We do this one. So you can be able to see we have a product. We have a product of two functions. One is the trigonometric and the other one is algebraic. So I'll call the first one u, and the other one I'll call it v, and 10x. Then I'll come and differentiate this one. This one always, we move always from the left to the right. So I'll have here du all over dx. Differentiate this one, you get 2x. This one I'll have dv all over dx. This one now, you see now, there's no need of introducing chain rule, the u. That's why I was saying we can y is equals to x squared sin x. We have a product of two things. We want to come and apply the product rule, and I said one function I'll call it u. You can be able to see it, x squared. The other function I'll call it v sin 10x. So I had differentiated du dx. That one is an easy function. The power comes down, reduce the power by 1. So I was on this other function, and we said, from the previous calculation that I had done, we shall be able to use what? Chain rule. So when you differentiate sine, you will get cos 10x. But don't forget to come inside the function. When you differentiate 10x, you remain with 10. So this 10 will come in front, 10 cos 10x, the final answer. 10 cos 10x. Please don't forget to differentiate sine, you'll get cos, but come inside the brackets. When you differentiate inside the bracket, we'll get 10. So the 10 you'll be able to multiply. So I don't want to see something like this one. The final answer to this one is wrong. Some people write it like this, 100x. They multiply this one here inside. No, that one will be wrong. This one is wrong. You must be able to do what? You must be able to bring the 10. The 10 is multiplying the whole thing, is not multiplying inside the bracket. So when you do like that, you are wrong, kindly. So now it's a matter of now for me to be able to apply the product rule. So product rule says that dy dx will be given by u dv dx plus v du over dx. So I'll just apply the things. Our u is what? Our u is x squared. Our dv dx, we have gotten it as what? 10 cos 10x plus our v is sine 10x. I'm just taking the individual things the way they are, and then our du dx was 2x. So when you have differentiated, you just have to input it on the formula and then you simplify. So you can be able to bring the 10 in front. So I'll have 10 x squared cos 10x. Can be able to bring the 2x in front plus 2x sine 10x, and that is the final answer for that. So the other one is a matter of just simplifying, bring the constant in front of the functions. Easy as that. So that is the product rule. I can still be able to do another example here. So y is equals to x to the power 3 exponential, let's say 4x. So first of all, remember we are under differentiation. You just have to remember we are under differentiation. If you don't differentiate a function, then it means you are not under calculus 1. We are differentiating. So here you can be able to see we have a product. If I was to read this function, it will be y is equals to x to the power 3 times exponential 4x. So there's a product. Even if there's no times, that is a product. So what I'll do, I'll call one function u. The first one I can be able to call it u, and then the second one I can be able to call it what, v. Then here I have u on my left hand side, so I'll have du. I have x on the right hand side, so I'll have dx. When you differentiate x to the power 3, you get 3. The power comes down, you reduce the power by 1. Then here I'll have here dv. I'm differentiating v in terms of x. So again, this one, when you differentiate exponential from the table, you'll get exponential 4x, no problem. But you come now to the power. Chain rule, you come to the power, differentiate now this power I'm circling. When you differentiate 4x, you remain with 4. So here the final answer will be 4 exponential 4x. Please don't forget about that one. I'm doing chain rule, but a faster way. So mine is to just apply now the what? The formula. So dy dx was given by u dv dx plus v du dx. So I'll just come and take my u. My u is x to the power 3. My dv dx. My dv dx is 4 exponential 4x plus my v. My v is exponential 4x. And then my du dx is what? 3x squared. So we said we just bring the constants here in front. So I'll have 4 x to the power 3 exponential 4x plus 3 x squared exponential 4x. So as long as you bring the constant in front, I don't have a problem. You can write it like that, or you can still be able to write it as 4 exponential 4x x to the power 3. I don't have a problem with this one, even like this. And then I don't have a problem. As long as the constant is in front, I think I don't have a problem with that. So I do example number 3. Number 3. So y is equals to cos 6x and then ln 4x plus 5. We do this one and see what we shall be able to get. So again, you can be able to see I'm multiplying two functions. I have the cos and the ln. So one I'll call it u. The other one I'll call it v. This one I'll differentiate, I'll get du over dx. So when you differentiate cos, what do you get? You get negative sign. The same function, 6x. But you come inside the power. When you differentiate here, whatever I'm circling here, when you differentiate 6x, you get 6. So here the final answer will be negative 6 sine 6x. Let's go now to the v, dv over dx. So when you differentiate ln x, you'll get 1 over x. So when you differentiate ln 4x plus, you'll get 1 over that, the whole of that, 4x plus 5. But you come inside now the brackets. This one I'm scribbling. This one inside the bracket. When you differentiate 4x plus 5, you remain with 4. So here the answer will be 4 all over 4x plus 5. So just look at the table. Ln, everything goes to the denominator, but don't forget to come inside the function when you differentiate and you multiply with that. So mine now have everything that I need is to apply the product rule. So dy all over dx will be given by u dv over dx. The formula is very easy to remember, this one all over dx. So what is my u? My u was a cos 6x. My dv dx was what? 4 all over 4x plus 5. And then plus my v is ln 4x plus 5. And then finally my du dx I got it as negative 6 sine 6x. So it's a matter of now simplifying, whereby you can be able to simplify. Like the first one, I cannot be able to simplify anything, so it will remain as 4 all over 4x plus 5. But here I have a constant 6. It is a constant 6. I can be able to remove it, bring it in front. A positive times a negative will remain with negative 6. And then ln 4x plus 5. And then sine 6x. So what I've done to simplify is to just to bring the constant negative 6 in front. Only that. That is a simplification. So when you have the formula, I don't think there's anything that is too hard there. I do the final one, number 4. I do number 4. Number 4, y is equals to 2 tan 3x you can be able to deal with sine hyperbolic 5x. So what you can be able to do, there's a constant there 2 here. If you prefer, you can still be able to take the constant as the whole of that one. I don't have a problem. So you can either take the 2, the 2 can remain the way it is, then you differentiate tan 3x and sine hyperbolic later, or you just take the what, you just take the what, the whole of it. So I'll take the whole of it to make my work easier. So I'll take you with the constant tan and 3x, and then I take here my v to be the remaining function, and then 5x. So here I'll have du all over dx. So remember the 2 is not playing anything, so the 2 will remain. So I differentiate tan. When you differentiate tan, you'll get sec squared. Go back to the table, sec squared 3x. But don't forget to come inside. When you differentiate 3x, you get number 3. You get number 3. So please differentiate the 2 will remain as a constant. Then you differentiate tan, you get sec, but come inside the function. So this one, the total answer will be sec squared 3x. Why am I getting 6? I'm multiplying the 2 and the 3. Then here I'll have here dv over dx. When you go back to the table, when you differentiate sine hyperbolic, you get cos hyperbolic 5x. But you come inside the function. When you differentiate 5x, you get number 5. You get number 5. You get number 5. So here the final answer will be 5. And then cos hyperbolic 5x. Now it's a matter of time now just to apply the formula. So dy dx will be given by u dv over dx plus v du all over dx. So what is my u? My u was 2 tan 3x, and then my dv dx I've differentiated is 5 cos hyperbolic 5x plus my v is sine hyperbolic 5x, and then my du dx was 6 sec squared 3x. When I have that one now, after inputting is to multiply the constant. So I have here, let me show you the constants that I need to multiply. This one here, I have a 2 here, and I have a 5 there, and then only that, and then I bring the 6 in front. So 2 times 5, I'll get 10 tan 3x, and then cos hyperbolic 5x plus, I can bring the 6 in front, so sine hyperbolic 5x, and then sec squared 3x. That is the final answer that I've gotten. So I'm hoping still the notes will be clear on this. This is what is there on the notes. It is not that hard. So you can still be able to go through the notes, and then you'll be able to see. I'll give an exercise later for you to be able to differentiate like 4 functions after this, and then you'll be able to tell me. Can I go now to quotient rule now? Questions will come later. Quotient rule. Quotient rule. Quotient rule. So quotient rule now deals with when you have a division, u over v. The formula states that dy over dx will be given by v du over dx minus u dv over dx all over v squared. So the formula is here. So again, you have to remember another formula. So it's only about the quotient and the product rule are only on what? They are only on remembering the formula. And again, you being good at what? At a chain rule. Only that. So when you have a division, we apply this formula. When you have a product, you apply the previous formula. So this is the formula. So when you have the formula, you have everything that you need. So let's do example 1. So then I'll not even do a lot of example. 2x squared plus 4x plus 1 all over, let's say what? All over 5x. We do a simple one like that one. You can be able to see the division. So quotient rule will apply. So this one is very, I'll be precise. This one, your numerator has to always be the u. So you can be able to see here, the numerator has to always be the u, and the numerator has to, if you interchange, then the formula will not work. So the numerator is always the u. Remember a, b, c, d, we always start with u, v. So u is always the denominator, and then v u is the numerator, and then v is the denominator. So, so this one I'll call it my u before I forget, and this one I'll call it my v. So that's what I'll do, and then I differentiate. So even before let us earn some marks of just differentiating. Just differentiate. So u will be given by 2x squared plus 4x plus 1. And then the v is what? 5x. So when you differentiate this one, du all over dx, this is 4x plus 4. The power comes down, you reduce the power by 1. When you differentiate one a constant, you get 0. This one dv all over dx will be given by what? When you differentiate 5x, you remain with 5. So those are the answers that we are getting. Now it's a matter of just applying now the formula. So dy all over dx will be given by v du all over dx minus u dv all over dx all over v squared. So what is my v? My v was 5x. Right, let me do it down here. That was 5x. My du dx was 4x plus 4. 4x plus 4 minus our u was 2x squared. 2x squared plus 4x plus 1. And then our dv dx, we're going to it as number 5. And then the whole of this one is under v squared. Our v is what? Our v, let me go up. Our v is 5x. So it will be 5x we square this one according to the formula. So this one is a matter of simplification, opening up the bracket. I can be able to multiply. So 5x times 4, you'll get what? 20x squared. 5x times 4, you'll get 20x. Then the 5 can be able to come. So when you multiply a negative 5 times this one, you'll get negative 10x squared. Again, it will still be negative 20x, and then negative 5. Remember, there's a minus. So when you multiply with everything with a constant 5, you'll get 10, 20, and 5. Then all over. When you square this one, you'll get 25x squared. There's something that can easily cancel here. You can be able to see. The matter of just simplification. The 20 and that one will go. Then I'll have this other one as 20x squared minus 10x squared will remain as 10x squared minus 5 all over 25x squared. And that is the final answer. So what I've done is this one here. I'm getting the 10 from there. I've subtracted those two. That's why I'm getting the 10. So the issue here is not even, it's just the formula. When you have the formula, this formula here, you can be able to do the product, the quotient, any formula. So it's just a matter of remembering the formula. Number 2, y is equals to exponential negative 2x all over sine 3x. We try this one. Again, you can easily be able to see it is our quotient. We are dividing two things. So this one I'll call it u before I forget, and this one I'll call it v. So here u, negative 2x, and then my v here is sine 3x. If you don't differentiate, there's something you are not doing. So here I'll get here du dx. I'm using chain rule, remember? So when you differentiate exponential negative 2x, you still remain with the same thing. When you differentiate exponential, you still get exponential. But you said you come to the power, when you differentiate negative 2x, you remain with negative 2. So here the answer will be what? Negative 2 exponential 2. So you can able to see, we are just differentiating the power, and then that constant is coming in front of the number. So the other one is still dv over dx. When you differentiate sign, you get cos 3x. But you come inside now, you come inside this function that I'm circling. When you differentiate 3x, you get 3. So that 3 will come in front. 3x. Now, it's a matter of now applying now basically now the formula, and I'm done. So the formula is this one, dy all over dx is given by v du all over dx minus u dv all over dx all over v squared. So I'll just take my v is sine 3x. I'll take my du dx. My du dx is negative 2 exponential negative 2x minus. Remember, it's always minus. And then our u is exponential negative 2x. That is my u. And then my dv dx is 3 cos 3x. And then all over what? V squared. Our v is sine 3x squared. What I'll just do, I'll just bring the constant in front. You cannot be able to simplify any further. So I'll bring the 2 in front. So I'll have negative 2 sine 3x exponential negative 2x. I can able to bring the other constant 3 in front. So I'll have negative 3 exponential 2x and then cos 3x and then all over sine 3x squared. And then I'm done with that. So the only simplification I'm requesting from you is to bring the constant in front. I do the final example, number 3. So y is equals to ln 5 minus 6x all over, and do cos x squared plus 1. So that one there. So what we need first of all is to call this one our u, to call this one our v. So our u is ln 5 minus 6x, and our v is cos x squared plus 1. So du dx. When you differentiate ln x, you get 1 over x. When you differentiate ln 5x, ln takes everything to the denominator, that is for sure. Very important. But you come inside the bracket now, chain rule, you differentiate 5 minus 6x, differentiate 5, that is a constant, you get 0. You differentiate this one, you remain with negative 6. So here the answer will be what? The answer will be du dx will be given by what? It will be given by negative 6 all over 5 minus 6x. Let me do this one, dv dx. To differentiate cos, you get negative sign, the same function, x squared plus 1. But you come inside the function, and you differentiate x squared plus 1, you remain with what? 2x. So here the final answer will be negative 2x sine x squared plus 1. Now I'll just apply the formula. So I think the hardest thing is remembering chain rule, what I'm doing, but the other thing is just applying the formula. So the formula dy all over dx will be given by v du all over dx minus u dv all over dx all over v squared. Let me take my v. I go back. My v is this one cos. So my v is I'll be able to do it here. My v is cos x squared plus 1. Then I take my du dx, the one that I've differentiated, which is negative 6. negative 6 all over 5 minus 6x, then minus. I take my, the formula is saying I take my u is ln 5 minus 6x, then I take my what? I take my dv dx, it was long, it was negative 2x, and then sine x squared plus 1. The whole of these one all over v squared. Our v was what? Let me go back up. My v was cos, it is cos. My v is cos, a bit lengthy but it's still okay. Cos x squared plus 1, the whole of this one squared. So what I'll just do is on the first, I cannot go to simplify anything, so I remain with cos x squared plus 1, and then negative 6 all over 5 minus 6x. But in the other one, I can go to simplify. I can be able to bring the negative 2x in front. So a negative times a negative will get positive 2x. I can be able to bring it in front. Then ln 5 minus 6x, and then sine x squared plus 1 all over cos x squared plus 1 brackets. The whole of this one is what? Squared, and that is the final answer. So when you just input the values basically there, I'll not have a problem with that. I will not have a problem when you input the values there. So let me pause. What the most important thing for you to be able to note are two for today's class. The first one is the product rule. The product rule. When you have when you're multiplying two things, so when y is equals to uv dy all over dx, you need to write this formula somewhere, so at least you can be able to do so. It's given by u dv over dx plus v du all over dx. The second one was the what? Was the quotient rule. Quotient rule, whereby you have a division, y is equals to u over v. That dy all over dx was given by v du all over dx minus u dv all over dx, and then the whole of this one under what? Under v squared. So you can hope to remember those two formulas, and then you remember what we are done on a chain rule, then I don't think you'll have any problem. And let me repeat something about chain rule. We have said when you have a function like this one, y is equals to, let's say, 2 cos let's say 20x. What we said on the quotient rule, when you're differentiating, no, not on the quotient, on the chain rule, the 2 is a constant because it will remain the way it is. But when you differentiate the cos, you get negative sine 20x, the same function. Cos, when you differentiate cos, you get negative sine. But now you come inside now here, the brackets inside the function. When you differentiate 20x, you will get to 20. So here the final answer, when you multiply now all this, you multiply the 2 and the 20, you remain with what? With the negative. You'll get negative 40 sine what? 2x. That's what I had said. When you're dealing with what? When you're dealing with, they are called what? These are trigonometric. Then I went further and I did for the what? I did for the exponential, 7x. When you differentiate a exponential, you still get exponential. You still get exponential function. But now the difference, what is coming, is now on the power now. When you differentiate the power, you get 7. So you multiply with that. So the 7 will come in front. Simple as that. When you go to ln, let's say 10x plus 1. When you differentiate ln, what ln does, it takes everything to the denominator. Differentiate ln x, you get 1 over x. So it will get 1 all over the whole of this one. But you don't forget to come inside now the brackets. When you differentiate 10x plus 1, you remain with 10. So the answer will be what? 10 all over what? 10x plus 1. So those are the functions that are needed for you to be able to remember those ones. And now, if you do like what I'm doing, you have become like I can say that the reason why I'm doing this is because remember when we are doing chain rule, we were introducing a U. But when you come to the quotient and product rule, there's still another U. So you might get confused. That's why I'm doing this one now. For the person who has done chain rule, they can be able to see how they are coming about. So, yes. So that's what I wanted to say. And I think I've created a discussion forum whereby you have 4 questions, 2 on quotient, 2 on product rule. You can easily move out from here, and then you'll be able to see what I mean. So, but before that, let me first of all answer